this talk as an introductory and overview, but I showed these slides to a colleague in the speaker room, and she's like, yeah, this is not that beginner. I'm like, oh. So if you're a beginner, welcome, please stay. I'd love to hear your feedback after the talk. So I think this will be fun for a wide range of folks. All right, so I mentioned I am a book author. I'm a co-author for O'Reilly's Programming Android with Kotlin, Achieving Structured Concurrency with Coroutines. It was published in December 2021, and I found out recently there will be a published version in China this month, so that's really exciting. So this talk is a spinoff of that book. O'Reilly gave me their blessings. I've created my own examples, but the concepts and explanations often do come from the book. So we, the authors, we've always had sincere intentions with this book. So while coroutine concepts are important to master coroutines, you don't have to understand everything right now to get started and be productive. So with that said, I'd love to establish some playground rules. So we're in the Recreation League. So we'll probably be doing things that we shouldn't do. And there is a caveat. If you want to follow along and try to follow along with the code, you can, but depending on what platform and which compilers you're working with, the coroutine results might run slightly different. And when I discovered that, I was like, oh, there's a lot more to play with. So, if you want to follow along and then find out, oh, it's like a little different, like try it on different platforms, see how it runs for you. Okay, some additional like small setup stuff. If you want to play with coroutines, logging's going to be one of your best friends. When it comes to regular debugging, trying to figure out what like the status of like the current coroutine is in relation to other coroutines is a little tough. So logging always helps. And I just found out a few weeks ago that there is an option you can put into your edit configuration. So like where it says the VM options, so you add the dflag Kotlin X coroutines debug. And that just brought like a whole new world for me. We won't be going into that too much, but if you haven't tried it yet, it's awesome. You can actually see all the coroutines you've created in the current state they're in at particular debugging points. Okay, so the topics, which I thought was beginner enough, is coroutine behaviors. So we'll be going over run blocking, launch, async, and also working with coroutine context. And we'll be kind of looking at ways with coroutine scope, standard coroutine builders, and with context. All right. Starting with run blocking. Run blocking, which returns some type T, is designed to bridge regular blocking code to libraries that are written in some suspending style. It's meant to be used for the main function and in tests. And outside of that, and you shouldn't be using it, but we're going to do it anyway. I'd like to say that run blocking has a hijacking behavior for the current thread. So let's see how that plays out in code. So we have very simplistic main function. It has that run blocking. And then we have a task 1 and a task 2, which is also run blocking. There are some logging statements, and there's also a delay in each task to kind of like simulate some kind of like background work going on. So can you guess what happens when we hit play? I'll give you a few seconds. All right, we'll go ahead and just get it going. So, the main function launches the run blocking on main thread. That'll be the first coroutine. Task 1, which is also run blocking, hijacks that main thread, and when the contents of that completes, then it releases the main thread before moving on to task 2. Task 2 does the same thing. It hijacks the main thread. When the contents complete, it releases the main thread before moving on. And then the program finishes and the main thread's released. This code works as if there were no coroutines at all. Very useless. So let's make things a little more interesting, see what happens when we wrap these tasks in a launch coroutine builder. We'll just keep building on, So introduction to launch. Pierre and I, that's the other co-author, we like to think of launch coroutines as a fire and forget mechanism. So in other words, there's no result to return. It'll start that coroutine, and what is returned is the reference to the job type itself. And you're able to work with that job using like the cancel call on its reference, and you're also able to use join, which forces the current thread to suspend until that particular job is complete. A job represents the coroutine itself like a handle on its life cycle. Okay, we're going to take the same bit of code we were working with and wrap task 1 and task 2 into a launch statement. Go ahead and take a few seconds to see what might occur. The faded text is to indicate what was there before, if that helps a little bit, like, save a little bit of time on how you think it might be different. So give me a few seconds. Okay, gonna hit play. And I don't know, just for funsies, did anyone predict this would happen? Raise your hand if you think you got it. Okay, fun, I love it. So results, for those that wasn't too sure, the results obviously look a little bit off. And we can see where the program ending got printed. So we say start job, we promptly call end, even though we kind of technically invoked the job first. And this is what I mean by fire and forgets. Because there's no results to return, there's technically nothing to wait for. So it appears that the reference to the job was created, but because the current coroutine from like the first run blocking was still in execution, that launch statement, the job, was politely waiting on that first opportunity to like butt back in. Luckily, we can fix this with a join statement. All right, so adding that join statement forces the current coroutine to suspend until the job is complete before moving on. Let's go ahead and make another guess how this might affect the behavior. I'll give you a few more seconds. Okay, we're gonna move forward, and I'm sorry, it's like not that many seconds. It's like we're going through a few of these, and I wish I could give you more time. All right, so we have everything going. We have the run main blocking. We started the job, so that's the new coroutine launch. And I didn't point this out before, but you can see in the logging, like sure we have like the regular logs, but then to the side of that, which is wrapped in the whole log bit, it indicates what thread you're technically on and what coroutine you're on. So, the coroutine 1 is supposed to indicate like the parent, which is kind of a reference to the actual main function. So then we go to start job, and then we go to job launched. And at that point, we have created a second coroutine. It's still technically on the main thread, but there is a second coroutine present. But because we have that job.join, we now have to suspend coroutine number 1 to wait for coroutine number 2 to finish, but coroutine number 2 has some child tasks. So then we go back to run blocking. We know what the rules for run blocking is. We just have to finish whatever's in there and not move on until that's completed. There is no like play interruption. It's just we got to finish it. We're taking all the space, all the room. We've finished task 1. We start task 2. We finish task 2. There is an implied delay in there. So if you ran this in real time, it'll eat up some time. Then your program will finally end after the job has completed. So then you go back to coroutine 1. Okay. All right. So we have wrapped both of those tasks in the launch. But I think we can go ahead and see how all of this like slightly starts changing a little bit if we just alter task 1 to be a launch coroutine builder instead of a run blocking one. Okay, I'm going to give you a few more seconds, and the gray text is to indicate what we previously had, and just take a few seconds to think about how this might be different. All right. All right. So job is launched, and it looks like the main difference, I'm so glad I highlighted the difference. It's a lot easier to see. So we have task 1 launching, so everything's still kind of the same, but we're going to jump right into task 1 and task 2. When we start task 1, now we have a delay. Remember, the launch coroutine is interruptible. I don't think that's how you pronounce that, but once we hit the delay, technically that particular coroutine number 3, is now paused and suspended, and task 2 is like, oh, this is my chance. So task 2 occurs. I'm not sure if this is 100% the right thing. I feel like the correct thing, and feel free to call me out if someone else is doing this with me, but it should be run blocking, so it should finish because it's unable to be interrupted. And then task 1 should finally complete. So I believe task 1 complete and task 2 complete should actually be switched. If someone finds out, feel free to shout out so we find out. Okay, let's keep going. We're going to go change run blocking now to a launch. Okay. And, it looks like we're adding one more launch too, because I know working with 2, it starts feeling a little simplistic, and it's like, wait, like how, is it just like alternating? Like, what are we doing? So I figured adding a third one in might make the picture a little bit more fun. So take a few seconds to think about how this might work out, and I'll hit play in a few seconds. All right. Did anyone get this? Raise your hand if... Ooh. Okay. No, yeah, it starts getting like crazier every time. So I gotta say about half the room is not bad, probably more. People are shy, like this is a quiet room. So yeah, we have task 1, task 2, task 3. Just for clarity, I'm gonna go ahead and let's see how we do on time. Yeah, we're doing good on time. I'm not in a rush, so we can go ahead and talk about it. All right, so we already know about the start job and the job launched. So we're gonna jump right into the contents of the job itself. So task 1 launches. There's some task 1 statement that prints. We hit the delay. That means that it is able to be interrupted. So the next possible thing that could interrupt it is task 2. However, after printing out the first statement, that delay gets hit. And then the next thing in line is like, oh, great, it's now my turn to interrupt. They go in, except they stop for a little bit. So what happens from that point? That means the next step in what was available in task 1 resumes, but since that completes, we release the reference to the thread, then we go to task 2, it's able to complete, and so on. So we have that. We're going to add a little bit more. So we know about joins, we know about launches, we know about run blocking. Okay, so let's play with execution order by forcing the program to wait on task 1 and task 2 to complete before starting task 3. Okay, so if we do this, what do you think will happen? I'll give you a few more seconds. No, this is kind of fun because what really inspired this talk was like, sometimes you really think you know coroutines, and then 5 years later, you're just kind of sitting at this one bug for 5 days and you're like, I thought I knew how it works. So like this is, obviously this is really simplistic, but I think it's fun watching everyone like try to figure this out. I'm sure this feels somewhat remnant of, or it feels maybe a little familiar to like some of your worst coroutine issues. But in a much nicer, like easy, fun playground setting. So, all right, I think I've given people enough time. We're going to go ahead and see what occurs. So we have task 1 and task 2 launching and completing before task 3 ever starts. So to be specific, task 1 launches, then it prints, then that delay gets hit in task 1. We already know that where we can kind of expect that task 2 is going to launch, then that delay hits. But because we added those join statements, we hit that second delay, and then we resume task 1. So we go back to flog. So it doesn't seem that different, but if there were more contents within that, unless there was like another interrupting point, like it would just finish all the way. And the same would be true of task 2. So upon completion of both, then task 3 is safe to start. And it does look like it's in order, but if maybe there were like more tasks on the bottom, then it would just kind of like you would apply these small rules like exponentially. So, okay, task 1 starts, there's a delay and it completes just because there's nothing else to interrupt it. So it just kind of executes in order without anything else interrupting it. So there's no more work to complete within that job. And so the job will finish at job.join, and then we can call program ends. Okay, so I think we have a pretty good idea of what run blocking and launch does. We'll move on to async. And async creates a coroutine and returns its future result as an implementation of the deferred type. Deferment, I looked up the definition because I don't know, I like to be literal sometimes. I think sometimes it's helpful because sometimes you're just like, yeah, I know what deferred means, but then you start thinking about it like in coding and like how it actually acts in real life. And it's always nice to like see, oh yeah, like that definition in the dictionary like matches exactly what it should be doing. So deferment is to put off an action or an event for a later time, to postpone. So when you call that async coroutine builder, it'll start that coroutine and it creates a deferred instance which returns the value t on completion. It's good to also know that deferred is also a job type, so you're able to call cancel and join if you wanted to do that. But yeah, and the more important part is that deferred has an await method, which is used to wait for the completion of whatever calculation or task itself. Okay, so we're going to take our previous example and change task 2 to become async launch. Okay, you know what to do. I'll give you a few seconds, and I'm going to think about it a little bit too without cheating. This one will be a little bit harder because I moved the log for task 2 await like a little bit further down. So now we have to think about it a little bit harder. So there might be a few changes. I'm not sure if I highlighted the differences for the next one, but I'll try to call it out as I see it. Okay, I'm going to hit play. Okay, so I'm just going to skip right to the job. We go to task 1, that starts, we print out task, we hit the delay. Then we start task 2, which is a deferred instance. But then we print that, we hit the delay again, and task 1, which is already kind of like in that queue, like, oh good, it's my turn. So I'm going to complete because we happen to have nothing else to do with that. So task 1 ends. Then what gets interesting is, you know, down the line we have task 3, which is invoked. Let's see. But we don't call it quite yet. We jump straight to the log for task 2 status for task 2. This is kind of fun because when you print out like the actual reference to the deferred itself, it actually gives you the status of that current coroutine, which is kind of fun. So it gave us an active status at that time, and then we go to await. We go to task 2. Oh, sorry, lost my spot. We had task 2. Okay, now we go to task 3. We have task 3. It prints out task 3. We hit the delay. When we hit that delay, then we go to task 2 status again, which is completed at this point. Now that's really interesting because we have that completion, and then afterwards, Did I ever actually print the return? Oh, that is the return. I should have cleaned it up a little more. That is like the completion of the return. So we have task 2 status. I see. Okay. There's a lot of text in here. So what it was actually supposed to return was task 2 complete. I forgot to clean up the code, and what should be in task 2 status, which is like that, the log awaits, that should be present. Then we complete that, and then it goes to task 3, which is like the only thing left in the queue, and we finish. Okay. So sorry, there was just like so much code to write, and when I publish these slides, I'll be sure to look closely like at some of the cleanup for some of that. So we're gonna go, all right, we've looked into async tasks. We learned a little bit about how we can play with the return function and how it kind of interacts with launch. We're moving along pretty far and we're making pretty good time. So that's nice because the next section is actually more dedicated to Android related code. You know, a lot of that was basic stuff, but we're going to go ahead and go on to coroutine context. So coroutine context usually relates to the persisted context of the coroutine that you're currently in. And it's really important because it designates the task that you're on. It designates what it should execute on. And it could be, depending on what dispatcher you're using, it would be a thread or a thread pool. And we'll go into that a little bit more in a bit. It's really important because being able to change the coroutine context is the ability to make tweaks or alterations to the behavior of concurrency. Because, you know, I mean, when people are like, can you control concurrency? And like the answer today is even like, yeah, well, you can like tweak it, but you don't have like full control over it. You really don't. And that's why like Rahman, he's like written a lot of talks on like structured concurrency. It's like a lot of like really excellent work. So definitely do a lot of like research around it, play with it yourself. But yeah, so we're going to talk about how we can change coroutine context. There are 3 main ways: coroutine via coroutine scope. I put in launch context, but what that really means is all standard coroutine builders have the ability to allow you to designate what context you're using it for. And then there's with context, which takes a context. They all take a context parameter. All right. Take the case of this main activity view model, which uses live data to reflect back in composable UI. I know live data is outdated, but if we started introducing flow, this talk is going to be like 2 hours long. So we're keeping the scope as small as possible. Okay, so main activity view model, it makes use of both the view model scope and the custom scope. The view model scope is located in the load contents, and you see that we have this like view model dot launch, and then like we have logging to indicate this happens. And then there is the scope.launch, and that scope was initiated earlier in the class, but done by ourselves. So it's a coroutine scope. And then I put in like a context pool. So this is like, I wasn't going to talk about this, but since the code's already in there, if you don't do this already in your Android code, it is totally recommended to kind of like create your own interface class so that you're able to inject the you can inject the dispatchers as a dependency because it makes it really, really easy for unit testing. So that's the TLDR. So we have this, and you might be wondering, well, like, what's the difference? So the difference, okay, so the view model scope in particular, the default itself is set to dispatchers.main. So it's when you launch view model scope without like any indication of anything else, it's going to launch on the main thread for Android. And it's lifecycle aware. So that's the other important part. And it's really nice because whenever the activity dies, then you don't have to worry about cleaning up like at cancellation or anything like that. View model scope is awesome. Use it all the time. Makes your life so easy. If you were to use a scope in your Android code, you want to make sure it's for something that's maybe like not related to Android lifecycle at all. Maybe something for like super, super specific tasks not related to Android. And something that might be super heavy. So this is like another way that you can create more control and structure around your coroutine flows. So within, when load content is called, view model scope launches this activity lifecycle aware coroutine. And within scope.launch then calls on do heavy work to start. Now the difference between view model scope.launch and scope.launch is that even though view model scope.launch is set to dispatchers.main, the scope.launch, we like set that ourselves to the default. So that will be running on a background thread. Okay. So do heavy work is a suspending function denoted by the keyword suspend. If you're not super familiar, the suspending function executes on the current context of the existing coroutine it was called for. And then within function execution, a suspending function may pause at suspending points to be resumed at a later time. Very similar to like the exercises we did previously. So when do heavy work starts, child coroutine launches within the for each statement. And it's possible to instantiate without that context argument for those standard coroutine builders because that default was assigned to the scope itself. And when we hit play, this is like the same exercise as before. I will give you a few seconds if you haven't already tried to figure out like what's going to print. All right. Not a lot of time, but we're going to... Yeah, okay, so view model scope launches. It starts on the main thread, as we talked about. Then the scope is launched, and you can see here that there's a default dispatcher, worker-2, worker-2, and then we print out those tasks, and it's like default dispatcher worker.1. Like, what's all that about? You know, just hopefully it's the next slide. Well, it'll be covered in the next few. So we see all this happening. We do know it's like technically operating on this default dispatcher, but yeah, well, there are these workers. So the dispatcher default is the default context argument. So when we're going through the other examples before with like just the launch, no parameter, just go to the block, async, all that, all those standard builders are defaulted to the dispatcher's default. So it's usually not necessary to like indicate this every time. So it's good to know that. So yeah, writing out dispatchers.default would like technically be the equivalence. So here's the thing about those workers. The dispatchers.default is backed by a shared pool of threads on the JVM and native. So this is why if you run the same code again, you might see like different workers being used for the same exact code. So you can see here like some of the 2s and 1s shifted, and now there's like even a 4 in there. So the number, and here's like kind of the other interesting aspect of it, the number of threads used by the default dispatcher is equal to the number of CPU cores, but it is at least 2. And of course, you want to use this generally for heavy CPU related work. So yeah, it's best for those CPU intensive tasks. And if we change the dispatcher to IO, the interesting thing is you will still see default dispatcher workers still being used as workers. I did not give you any time for that. Apologies. But so dispatcher's IO and its views share threads with the dispatcher's default. So using the IO dispatcher when already running on the defaults typically does not lead to actual switching of another thread. Of course, it's like IO is perfect for IO tasks. And the big thing here is since threads in this pool is expected to spend most of the time in a non-running state, it just makes it ideal for a lot of those networking related things. I think, I forgot it. But there are up to, I believe, 64 available parallel threads to work on. So these are it's really intensive. So just be mindful which context you're using so that you don't have unnecessarily expensive code. Okay. Let's see. Failures my spots. No, we have the dispatchers IO. We already talked about that. And we're going to go to dispatchers.main. We're already a little familiar with it, but I'm going to give you a few seconds to take a look, because you can see here it looks very similar, except it's all just being executed on main. If you try this code out, like in your Android Studio, one difference that I do not discuss here is like the timing difference. So like this code actually does run a lot slower than some of the other code. Okay, let's move on to with context. I know we talked about the load content a little bit, but yeah, so we have this like load screen method, and then within that we call do heavy work. So yeah, there's that do heavy work, and we covered that part. I have like this kind of fun custom results where we indicate a success or a failure, and then after that we update the view state value with main view state contents, result data, or a main view state error. I'm going to give you a few seconds to think about what might happen here, and we'll run it in just a few. Okay, so this one is a little bit of a curveball because the application actually crashes. In case it's not super readable, there's the fatal exception, default dispatcher worker 2, legal state exception cannot invoke set value on a background thread. And then you can see it tried to set it at the live data. So you're like, yeah. So this is where with context actually comes in to be super helpful. So when you're working with view model scope especially, being able to use that with context is how you like change the context of what you're working with within like the same set of like tasks and subtasks. So we did all that heavy work, and now that we've returned this value, we want to make sure that we're updating our UI on the main thread. Duh, right? So we can use with context to use the dispatchers.main. So yeah, that's kind of like the quick lesson there. I love it. It's very easy to use. I'm sure folks are familiar with that. Maybe not everyone. I did say this was for beginners, but now I don't know anymore. Yeah, so this is our dispatchers.main. We actually got through a lot of what I wanted to get through. I was like kind of worried that I put in too much, but it looks like we're still good on time. I did write some Medium articles on these 3 areas, and they're kind of like a little bit more lab-like. So if you'd like to find like a write-up for like an interactive version of this talk, that is there. I gave my link to my Medium profile because the first 3 articles are that. So I'm sure I'll like cleanly create like a navigation for it. Also, thank you for like sticking around for the talk. There will be a book giveaway probably tomorrow. Just pay attention to the droidcon socials, and you can come find me in the Golden Room tomorrow for a book giveaway and signing. Don't know when. I think you just gotta listen to droidcon and see whenever that will be. Yeah, and then like these are my socials. I mostly go on Mastodon at this point. That's like kind of where I do the ish posting. But yeah, please definitely follow me. There will be more spin-offs in the future. You know, it's just a lot of fun to like take these concepts and like just be able to create more experiments and like deeper understanding. So thank you all so much. I really appreciate all of you sticking through the talk. I do think we have a few minutes for questions. We may have like roughly 5 minutes if anyone wants to ask anything.